Hello, and welcome to the supplemental video series for Intermediate Algebra. My name is Kelly McCarthy, and I'm your professor this semester. The purpose of these videos is to give you a few extra examples worked out with me so that you have a better understanding and some more explanations for the concepts that you're already watching video lectures for in addition to these. So please do not use these as your sole lecture. This is, again, just to be extra examples worked out for you. We're going to start today looking at solving linear equations. Fundamental rule for solving a linear equation: what you do to one side, you have to do to the other side. And we're undoing our operations in the order of operations. So let's look at a couple examples. These are just going to be some various types of equations and some techniques that you might use to solve them. What's important to remember is that the way that we choose to solve an equation may not be the way that you choose to solve an equation, and there are definitely different approaches for solving linear equations. If you have any questions whether or not your method is acceptable, you're more than welcome to bring that to class and ask me. So the first one, 3x plus 6 equals 12. To solve this, we're going to subtract 6 from both sides first. 3x equals 6. Divide both sides by 3, x equals 2. So this is a nice simple example. And when we get our solution, if you wanted to check that, you'd simply take your solution, plug it back in for x in your original equation. 4.5 equals 3 plus 2.5x. What makes this example different from our previous example is the decimals. Now, you can always work with decimals. However, if you would prefer not to, in the event that you didn't have a calculator or you just wanted to be dealing with whole numbers, you can clear the decimals by multiplying by powers of 10. So in this equation, since both of our decimals only go to the tens place, we are going to multiply everything in my equation by 10. Make sure that you distribute that 10 to every single term. So we get 45 equals 30 plus 25x. And now that we've cleared the decimals, it's a little bit more comforting in terms of solving. We're going to subtract 30 from both sides. 45 minus 30 is 15 equals 25x. And to isolate x, we divide both sides by 25. Now, when we get x equals 15 over 25, it's important that you guys remember, this is my policy. I want you guys to make sure you simplify this fraction. Do not give me a decimal as your answer. So when we simplify this, both of these values are divisible by 5, so this is 3 over 5. Negative 2x plus 2 minus 3x equals 8x plus 20 minus 7x. For this example, when we see that we have like terms on both sides, we want to simplify our equation first by combining like terms on the left and the right side. So on this left side, we've got a negative 2x and a negative 3x. Keep the sign that's in front of the coefficient. And on this side, we've got an 8x and a negative 7x. Negative 2x minus 3x is negative 5x. We still have the plus 2 equals 8x minus 7x is 1x. We don't typically write that coefficient of 1. If you put it, I won't mark it wrong, but I will circle it, let you know that it's redundant. You don't need that. And we still have that plus 20. So now we've got an equation with variables and constants on both sides. And we know that we want to get all of the x terms together on one side, all of the constants together on the other side. One thing to think about is an opportunity to avoid common mistakes. A lot of times students have issues dealing with negative signs. Not that they don't know the rules for negative signs, but we tend to make very careless mistakes when we're dividing by negatives. So if I look at this example, negative 5x plus 2 equals x plus 20, what I want to do is combine my x terms first to try to avoid that negative coefficient. Now the way to do that is by adding 5x to both sides. We see that when we do that, we end up with a positive 6x and then we'll divide by that positive 6, which isn't a problem. If you kind of think back, had I subtracted x from both sides, I would have ended up with negative 6x. Again, it's not wrong to do it that way, but if you can avoid that opportunity to make the mistake with the negative, I encourage you to do that. So we'll subtract 20 now. Again, we're trying to isolate that variable. We're trying to isolate x. 2 minus 20 is negative 18 equals 6x. Divide both sides by 6. X is equal to negative 3. Again, in the event that you have plenty of extra time while you're taking a test or working on an assignment, I encourage you to plug that answer back in to make sure that the answer is a solution for the equation. 4 times the quantity x minus 2 equals 6x minus 10. We want to first clear the parentheses, so we're going to do that by distributing the 4. 4x minus 8 equals 6x minus 10. And now we're faced with that same decision that we have to make as to how we're going to combine our terms. I'm going to start by combining my variables first to try to avoid that negative coefficient on x. To do that, I'm going to subtract 4x from both sides. Negative 8 equals 2x minus 10. Add 10 to both sides. Negative 8 plus 10 is 2. Divide both sides by 2, we get x equals 1. All right, so let's look at this next example that involves fractions, which are everyone's favorite, I'm sure. But typically not, actually. So in order to clear the fractions, we want to multiply through by the LCD, the least common denominator. Now, when we clear the fractions, that doesn't mean that our answer won't necessarily be a fraction, but it just means that when we're moving terms and combining like terms, we're not going to be dealing with fraction coefficients. So if I look at this example, my LCD of 6 and 8 is going to be 24. Both 6 and 8 are divisible by 24. Now, you could have also used any common denominator, such as 48, which is a little bit easier to identify by just multiplying 6 times 8. That will work. At the end, you'll have to simplify your answer. So I'm going to multiply everything by 24. Now, this next step I'm going to show you is going to come into play again in our chapter 6 on rational equations. This is, in fact, a rational equation. That's an equation that involves fractions. What I want you guys to do in the next step is actually show the distribution. Show that 24 being multiplied by each term. So we've got 24 times x over 6 minus 24 times x over 8 equals 24 times 1 over 8. Now, the reason I want you guys to show this is because then it will be easier to simplify each term. We won't make any mistakes. 24 divided by 6, we can simplify first, is 4. So this first term becomes 4x. 24 divided by 8 is 3. So we've got minus 3x. 24 divided by 8 again is 3. 3 times 1 is 3. Now we're dealing with a very simple linear equation where we can combine like terms to solve for x. 4x minus 3x is just 1x, and that equals 3. Again, we will see more equations just like this one in chapter 6 on rational equations. X minus 1 over 3 plus 2 over 3 equals x minus 2x plus 3 over 9. Same thing. We want to first clear the denominators or clear the fractions by multiplying through by our LCD. In this example, our LCD is going to be 9. Remember that this x is x over 1, so if you wanted to make that term a fraction, you could do that by putting it over 1. And then our denominators 3, 1, and 9, our LCD is going to be 9. So again, we're going to multiply everything by 9, making sure that we distribute to every single term. And in that next step, I'm going to show that distribution to every single term. So I have 9 times x minus 1 over 3 plus 9 times 2/3 equals 9 times x over 1, or you can just leave it as x, minus 9 times 2x plus 3 over 9. So now I'll go through and I will simplify each term. 9 divided by 3 is 3. 9 divided by 3 is 3. 9 divided by 1 is 9. 9 divided by 9 is 1. But be very careful of this negative sign. That negative sign is still sitting outside of these parentheses. So rewriting what we've got, we have 3 parentheses x minus 1 plus 3 parentheses 2 equals 9 parentheses x minus 1 parentheses 2x plus 3. And now to solve, we're going to have to distribute. We need to clear those parentheses. So we will distribute this first 3. The second 2 terms are just going to be multiplication. And then in this last one, we're distributing that negative 1. So we have 3x minus 3 plus 6 equals 9x minus 2x minus 3. Be very careful distributing that negative. Combining like terms on the left, we've got 2 constants. On the right, we've got 2 x terms. So we have 3x plus 3 on the left-hand side and 7x minus 3 on the right-hand side. We add 3x to both sides. 3 is equal to 10x minus 3. Add 3 to both sides. 10x equals 6. And I'm going to come over here since I'm running out of space. Divide both sides by 10. X is equal to 6 over 10, which we are not going to write as a decimal. We're going to simplify this fraction. Both are divisible by 2. X is equal to 3 over 5. Let me check this because I have a different answer. Oh, all right. So I found my mistake, and this is something that you guys are going to have to be very careful with. If we look back, and maybe you've already identified the mistake and noticed that in your work, in this step right here, notice how when I was combining my x terms, I added 3x. This should have actually been a minus 3x because it was already positive. To move it to the other side, we have to subtract 3x, which is going to make this 4x, not 10x. I'm actually going to erase that. It looks a little hard to read here. So this term right here, we should have had 4x minus 3, which changes this one right here. 4x equals 6. Again, I'm just going through and fixing where I made my mistakes, guys. I don't have to erase everything because not all of it was incorrect. 6 equals 4x. Divide both sides by 4. We get x is equal to 6 over 4, which will simplify x equals 3 over 2. Again, make sure when you end up with a fraction as your answer that you simplify that fraction. A lot of students want to take that 3 over 2 and write it as a mixed number. My personal opinion on mixed numbers is that their only home is in a recipe. So please do not use mixed numbers in your final answer for problems that I give you. .2x plus 0.1 equals 0.12x minus 0.06. So here we have another example that involves decimals, and remember that we're going to clear the decimals by multiplying by powers of 10. Now, if you look at all of your decimals, if I just multiply by 10, will it clear every decimal? The answer is no, because on this right-hand side, my decimals are to the hundredths place. So in order to clear all of the decimals, we are going to multiply by 100. Again, golden rule, the foundation for solving equations. What you do to one side, you have to do to the other side. You have to do it to every single term in that equation to maintain balance. So we've got 20x. Multiplying by 100 is the same as moving that decimal place 2 to the right. Plus 10 equals 12x minus 6. Subtract 12x from both sides. 8x plus 10 equals negative 6. Subtract 10 from both sides. 8x equals negative 16. Divide both sides by 8. X is equal to negative 2. Now this technique of clearing the decimals first, you don't have to do that. But a lot of students, although they think that decimals are so much easier to work with than anything else, if you have that decimal point in the wrong place for any of those values, it's going to change your entire answer. So just be very careful with that if you choose to leave your coefficients as decimals. 5x minus 1 equals 5 times quantity x plus 3. Very straightforward. We're going to start by distributing that 5. 5x minus 1 equals 5x plus 15. Now we're going to start to combine like terms. I'm going to subtract 5x from both sides. And what do you notice? On both sides, my x terms cancel out, or they sum to 0. So I end up with negative 1 equals 15. Well, look at this statement. This statement says that negative 1 is equal to 15. Is negative 1 ever going to be equal to 15? No. So this means that there is no solution for this equation. When there is no solution, we call this equation a contradiction. Negative 4 times quantity x minus 1 equals negative 4x minus 9 plus 13. Again, we'll start by distributing that negative 4, the whole coefficient, the negative 4, into the parentheses. So we have negative 4x, negative 4 times negative 1 is positive 4, equals negative 4x, negative 9 plus 13 is positive 4. Now, if we look at this, think about, do you have any observations? I'm not going to tell you what you might see, but we'll talk about it in a minute. But think about it. Look at this equation here and see if you notice anything. Now, if I continue just solving like I normally would, I'm going to combine my x terms. So I'm going to add 4x to both sides, and I get 4 equals 4. Well, now look at this answer. We have a statement that says 4 is equal to 4. When is 4 equal to 4? It is always equal to 4. Since it's always equal to 4, that means that all solutions will work for this equation. There are infinitely many solutions. Or we can say that the solution is all real numbers. When we have an equation that solution set is all real numbers, we call that equation an identity. Now, in the last two examples, we saw an equation that had no solutions, which was called a contradiction. And then this example where we had infinitely many solutions, we call that an identity. In the first, however many examples we had one solution. And an equation that has one solution is called a conditional equation. In other words, that equation is true based on a condition that x is equal to that value. So as long as there is a finite number of solutions for the equation, we call it a conditional equation. Now we're going to look at some formulas. We're solving equations for an indicated variable, which is exactly what we were doing before. In all of the previous examples, we were solving for x, but that happened to be the only variable in the equation. When we look at this next example, d equals rt, now we have three variables, but our goal is still the same. If I'm solving for r, that means I want to isolate r. In other words, get r all by itself. So if here's my r, I need to get rid of that t somehow. The operation between r and t is multiplication, so to undo that, we're going to divide both sides by t. And we get r is equal to d over t. Again, we don't end up with a numeric answer, but we're still solving that equation for a variable. 5x plus 2y equals 10. We're going to solve this for y. So here's my y. Let me do that in red. That's what I want to get all by itself. So I want to move everything else. I'm going to start by undoing my addition subtraction, which is the 5x. I'm going to subtract 5x from both sides. I have 2y equals negative 5x plus 10. If you had written this as 10 minus 5x, it's the same thing. Now I'm going to divide both sides by 2. Y is equal to, you can leave it as negative 5x plus 10 over 2, or you can split up this fraction. This is negative 5x over 2 plus 10 over 2, and then this fraction you can simplify. Either of these solutions would work. Okay? Now, some of you might recognize this type of problem. If you've been graphing linear equations, a lot of times we start with a linear equation in that form. We want to solve for y, and this actually puts it in what's called slope-intercept form, which makes graphing a line very, very easy, which we'll see later on in the semester. A is equal to 1/2 times the quantity big B plus little b times h. We're solving for big B. Okay, so we need to undo everything that's on the outside of the parentheses first. So if I'm looking at this h is being multiplied, so I'm going to divide both sides by h. Those h's go away. I've got a divided by h equals 1/2 times the quantity b plus b. Now I want to get rid of that 1/2. To undo being multiplied by a fraction, we can multiply by its reciprocal. So I'm going to multiply both sides by 2. So now I have 2a over h equals, those go away. And now that I've gotten rid of that 1/2, I no longer need the parentheses, so I have big B plus little b. And now I will subtract little b from both sides. We have b is equal to 2a divided by h minus b. Notice that little b is separate from the fraction. It's not included. So that wraps up solving equations, solving linear equations. Some things to keep in mind: always make sure whatever you do to one side, you do to the other side. Also, understand that the way you approach solving an equation might be different from your neighbor, your classmate, even from me, and that's okay. The only thing I ask is that if you're deviating from the way that I'm showing you in class, that you at least show it to me or show it to somebody in the lab or something, just to make sure that you're not making a mistake and just happening to come across the right answer. Okay? So we'll see you guys next time. Have a good one.